Okay, welcome back, everybody. First of all, I have to apologize for the fact that it takes time before I release these new lessons of our data science class, particularly in the statistics part of probabilities part of data science. No, I'm just trying to work on some other things in order to see how best I can present it to you. You understand? I have to make sure everything are in place so that you won't lack behind, and I have to look for a method to simplify every bit of what I'm doing. So, in order for us to have a very grounded understanding on what we are doing, the most important thing is the ability to comprehend what I'm saying or what I'm teaching, and that is far more important to me than making sure or than filling up or piling up lessons. Like I need to make sure that you guys understand every little thing that's been taught, and that is the most important thing for me. I'm not interested in, you know, making up videos without caring if you guys understand or not. But I'm much more interested in you understanding than in me making more lessons, and that is that. Last times we were talking about we were having a section on we did factorial and we got to two factorials and we hit a snag. I was to prove um, a situation where we have say n factorial divided by what k factorial, where k is greater than what where n sorry where n is what is greater than k. Let me zoom a little bit so that we can have a very perfect visual. So we are trying to prove this kind of situations. When we're discussing about the properties of factorial. So we got to two factorials and we hit a snag. I was confused as to, okay, why wouldn't it work? Why didn't it? So, but now I think what happened was not really something to have happened, anyways. Sometimes sometimes we try to make a call to our what we've stored in our mind, and it's not coming forth. Anyways, but that being said, so the fix for it is this, the act for it is this. Now, I told us when we have something like this, the when we have say n factorial divided by k factorial in a situation where n is greater than k, it will give us what we have something like k plus 1 times k plus 1 times say k plus 2 times say what again, k plus 2 times up till say n. You understand? So the proof of this is like, okay, let's assume n is 7, and of course k equals what, let's say it's 4 adventure. Of course, you agree with me that n is greater than what k here, because n is 7 and k is what 4. So invariably we will have what, looking at the formula above, we will have something like say 7 factorial divided by what, k factorial. That's what I mean, sorry, 4 factorial, because we need to substitute for sorry, excuse me, we need to substitute for um k and 7 respectively. So now what we'll be having here is that is what we'll be having here invariably is, say we have 7 factorial. You agree with me that 7 factorial is same thing as saying 7 say 7 times 6 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 7 factorial, all divided by what, 4 factorial. 4 times 3 times 2 times 1. Now if you take a look at this, this 4 times 3 times 2 times 1 will be what, will be cut off from here. That is divided by this. You understand? By dividing this by this, you are really saying this and this will be what, cut off. You understand? 4 times 3 times 2 times 1 will be cut off from here. So we will now be left with what? We'll be left with say 7 7 7 times 6 times 5 and that's what we'll be left with, because 4 times 3 times 2 times 1 has been chopped off as a result of the whole thing being divided by 4 times 3 times 2 times 1. So we'll be left with this. So when you try to substitute this formula into here, if you are try to substitute what you have here into here, of course you will get this. So that is just the quick fix for that anyways. So in case you are still confused, you know me, just ask me, and I will do my best to answer. I've not always been I'm not this kind of person that I don't ignore messages. So except that it is not a meaningful message, but if you send me something that has to do with this, of course I'll be glad to uh, I'll be glad to reply to you on that. I'll be glad to solve or to provide a solution to your queries. Now, right now, we're going to be dealing with, let me clean this off. We're going to be doing variations. We had um, three types of combinatories. We talked about uh, factorials, we talked about variations, and we're talking about that is factorials and under permutation, variation, and what and combination. So right now we're gonna be doing variation, variation, variations. Right now we're gonna be doing what variations. We have two types of variations. There are two types of variations. We have variations with repetitions. Let me write them out. There are two types of variations. There are two types of variations. There are two types of variations. We have let me just stop here. So we have one with what? We have variations with repetitions, variations with repetitions, variations with what? Repetitions. With what? Repetitions. So sorry. Okay, let me just say variations with variation with repetitions. And we have variation. Let me give it a space to make it a little cleaner. Variations without repetition. A repetition. So we have variations with repetitions and what variations without repetition. So we are going to be explaining them with examples. That is the variations with repetitions, and variations without what repetitions, so that we can see how they are working in practical. So let's first of all deal with variations with which is these variations with repetitions. So we can understand variations with repetitions fully uh, without first defining it. Actually, let me first give a definition of variations with repetitions before, or say uh, Um, let me just first of all give what definition of let me first of all give the definition of variations before explaining. Of course, you will know what repetition is. So let me say variation is the let me say it is the total let me say it is the total let me say the total number of ways we can let me say it's the total number of ways we can pick and arrange the total number of ways we can pick and arrange some elements. Total number of ways we can pick and arrange some elements. Say some elements of a given set. Say let me say some elements of a given set. You understand? So if you look at how we define permutation in our previous lecture, you will see some similarities, but just that the keyword in variation play a kind of syntactic difference. It plays a kind of syntax. By syntactic, this is spelling of syntactic. This is what I mean. Syntactic difference. So so permutation was defined as a number of ways we can arrange some elements. I won't write that, but I will just remind us what I said in our previous lessons. So that's why you don't have to skip each lectures. You have to start from it follows one another, it follows each other. There is one is built on the other, so you have to go back and and watch previous lessons so that you can follow through. So like I said, permutations was defined as the number of ways we can arrange some elements of a given set. This can also be with or without repetitions, like we're about to do. So the keyword difference is just is just this pick and arrange, pick and arrange. So in permutation, I we didn't give something as to pick and arrange. We are only doing that in variation. So we are only doing that what in variation. Variation. So a minute, let me adjust more. So so let me see. Let me give one example to explain what we how we are going to define our variations without repetitions. Let me give a practical approach to it. Now, let's imagine you checked in an hotel. Let's say, for example, I'm not advertising for any hotel here. It's just for educational purpose. Let's like for example, we say you lodged in Eco Hotel and Suites. So please, Eco Hotel is no sponsor of this lecture or video. I'm just using them for educational purpose. So let's imagine you checked in an hotel, say Eco Hotel and Suites in Lagos. Why going to the pool? A cool hotel would have pool and stuff. So you forgot your key card in the room. I don't know if you know what the key card is. A key card is just these modern Turkish doors that, sorry, I'm not advertising for Turkish doors. These modern doors where you have a kind of key, a kind of card that looks like ATM look-alike card that you used to you slash it against the door to open. You understand? It's so smart. You understand? So you forgot, let's assume you forgot your key card in the room and the door was already jammed. You understand? So the key card is just a smart card that looks like ATM, like I said. So it is used to open modern doors. So commonly found in an hotel. So now you are left with one option to gain entrance to your room. That is to say, you have to guess two-letter word. That is to say, you have to guess two-letter codes of the door with only, let's say the code is ABC. Maybe you are left with ABC to select from. Let's say ABC to select from. You understand? So suppose we choose A as the first letter. Suppose we choose A as the first letter and as the first letter to use as our guess. So to guess the second number, we are still left with what, three options. We can still, you know, for example, we have only three codes to choose from, and we have two codes to choose from three-letter words. So let's assume our first guess is what, A. You understand? Our second guess, we are still left with the option of choosing from A, B, C to C, because it is with repetition. You can repeat anything you pick. If you pick A, you can still repeat A. If you pick B, you can still repeat B. If you pick C, you can still what, repeat C. You understand? Because we are dealing with variation with what, repetition. So because there is room for repetitions, you can select from what, A, B, or C. Note that, let's note that regardless of the three letters to start with, we are going to be left with what, three options for the second letter, like I said. So therefore, the total number of variation we now have will now be, let's say because we have three options and we have to select two from three options. Let's say um let's say the total number of variation we will have is what, three times three, which is what, nine. You understand? The formula we use to calculate variation with repetition is this. Let me show you the formula. Let me draw the formula for, let me say, the formula for it is this. to calculate variation with repetition. This is it. Let's say v bar um raised to power what n subscript what p equals say equals n raised to power what p. So what is p, what is n? This is it. V bar, of course, I said v is just normal. We are just saying we just it's just for variation. V for variation. So the formula for it is what um uh, v bar np, v bar of np equals what n raised to power what p. Now n here is the this n is what is the total number of elements we have available. Then this p is the number of position we need to fill. Now, in our previous explanation, the hotel explanation, because we lost our key and we have to guess, we have only one option to guess from A, B, and what C. V by here, we now, because we have to select from these three options and we have two choices to make from what, from where, three options. So this P here mean is 2, and this N will be what, 3. You understand? So invariably we have n raised to power what, 3, which is what, 3. I mean n raised to power p, which is what, n is what, 3, and p is 2, which is 3 raised to power 2. So invariably we have what, 9. That's how I got 3 times 3. You understand? Of course it's the same thing as 3 times 3, which is 9. So 3 raised to power 2. Remember, don't forget, I said n stands for what, number of elements we have available. You understand? You understand? And p is the number of position we need to fill. So applying it to the door example, like I said, we will get what, this. We will get what, this. And of course, it gives us uh, a strong the formula has given us a kind of proof to the value I got by saying 3 times 3. So but if you could use any of these, let's say, okay, let's say uh, in a situation, let's say we are given a choice that we could use any of the 26 um, letters we have in English alphabet. Then the formula will now be what? Because we have 26 letters in alphabet, definitely the sample space is what, 26, which is what, so from this formula v bar n p will now be what, in this case, what is n? N will be what, 26, which stands for the sample space. You understand, the total number of uh, options we have available, and and p is what, the total number of position we need to fill. So of course n raised to power what, p. So invariably we can say 26 raised to power what, how many position do we need to fill? 2, because p here will now be 2, n will now be what, 26. So that is that uh, on variations with repetition. So the next one will now be what, variation without repetition. Variations without what, repetitions. So I think we've done variations with repetition. And if there's any question about on variations with repetitions, please let me know. So the next one will now be what, variations without what, repetitions, which is what, this. So if you have any question, please let me know. Thank you for your time, and God bless. And of course, I'm available to you on Discord. I'm available to you on Telegram. I'm available to you on WhatsApp. So if you have any questions, please let me know. Thank you for watching, and God bless you.